This is our high dive summative 1 presentation. In this presentation, we're going to be going over a Ferris wheel using trigonometry and finding out the height and horizontal position of a given person on the Ferris wheel, on top of figuring out how angles work on a circle. In our example Ferris wheel problem, we have a Ferris wheel that starts at the 3 o'clock position, is 60 feet in radius, 20 feet off the ground, and takes 60 seconds to rotate.
Question number 1 asks to describe how to calculate the height of the circus platform at any given time and include an example of us doing this. So in order to understand how to find the height of the circus platform at any given time, we need to understand a unit circle. A unit circle works almost exactly like a graph. However, the boundaries are the perimeter of a circle. A unit circle will show the distance from the center in an x and y coordinate as circled above. A unit circle rotates at 1 degree per second and has a radius of 1. However, unlike a normal graph, we need to find the x and y coordinates of any particular angle using cosine for the x coordinate and sine for the y coordinate. This is as a result of placing a triangle to connect the center to the point on the edge that you are trying to find. If you look at the bottom left, that's an example of finding the y coordinate using sine. I put 30 degrees, a radius of 1, and found half as the height at 30 degrees, which matches the unit circle. Now if we apply this to our Ferris wheel, we can do the same thing for 25 seconds of rotation. Our Ferris wheel rotates at 6 degrees per second, which comes out to an angle of 150 degrees. We can take the sine of 150 degrees multiplied by the radius and get 30 feet above the center of the wheel. Then we must add 80 feet to account for the radius and height of the Ferris wheel, which results in 110 feet off the ground at 25 seconds of rotation from the 3 o'clock position. So this is how you find the height of a circus platform.
Now that we've figured out how to calculate the height of the circus platform on the y position, now we can figure out the x position. Now the x position is going to be using cosine. If we look back at our unit circle, which was previously explained, we can see that we figure out the y coordinate, but what about the x coordinate? Well, the x coordinate, as you can see with the red arrow in the right picture, that's the horizontal or right movement. That's going to see how far over, and then how far up with the height do you need to go in order to reach your position. So in order to calculate that on the x-axis, we need to use cosine. Now, the equation for the default unit circle, or actually for everything, is going to be the cosine of degrees is equal to your x, or the distance you're trying to find, divided by your radius. So in this case, with the unit circle, we have cosine of 30 degrees equals x divided by 1. Now, since x divided by 1 is just 1, we just know that the distance for the horizontal position at 30 degrees is 0.866. Now, that actually meets up with the square root of 3 divided by 2 on the unit circle. Now, if we take that same logic and provide it to an example problem with our Ferris wheel, we can get our horizontal position at any given time. So we know that 360 divided by 60 equals 6 degrees per second. 360 degrees being in a circle divided by 60 seconds. Now, if we take the cosine of 6 degrees per second times 25 seconds of rotation, that's our example, where it says horizontal position going to be after 25 seconds, we get a position of, we get cosine of 150 degrees equals x divided by 60. Now, that then results in the number negative 0.86 is equal to x divided by 60. You might be wondering, that doesn't make sense. How could you have a negative distance? Well, it's not actually negative. If we do the math and multiply that times 60, it gets negative 51.96. And if you look at our unit circle example, you can see that where the arrow is, I put a dot, and that means that he's going to be left of the vertical axis. Now, the same can apply to your height. You can have a negative height if you're below the x-axis. But in this case, we get negative 51.96 or 51.96 away from the center of the 0, 0 at 25 seconds of rotation.
For question number 3, we were asked to create an equation for the height of the circus platform on a Ferris wheel. We were asked to identify the amplitude, period, and midline in our equation. Now, in our equation, the equation, as you can see, is h parentheses t equals 60 sine, parentheses 6t, plus 80. Now on the graph, you can see the period represented in blue, the amplitude represented in orange, and the midline represented in green. Now the midline is the line that runs to the middle of the graph. It should be equidistant from the peak of the graph and the trough of the graph. In this graph, it's represented in 80 and seen in our equation. Now the amplitude of the graph is different from the midline to the peak or trough of the graph. In this equation, it's 60. As you can see, it goes from on the graph, it goes from 80 to 140. That distance is equal to 60. Now the period is what is known as the rotation of the graph. It is different from a 1/4 rotation to another. So it'll be 60, as seen in the equation. It'll take 60 seconds for the graph to rotate.
Using the previously mentioned horizontal position, the way we figured that out, and then using the equation we used to get the height, we can then create an equation for the horizontal position. Now this equation is the horizontal position is equal to the radius times the cosine of your degrees per second times time plus 0. Now, in our case, this looks like 60 times the cosine of 6 times your time plus 0. Now, this results in, we can actually pull this equation apart. The plus 0 means a midline is 0. That means that there is no, for example, in y equals mx plus b, that's your starting position. If you have b as 10, that means that you're going to cross over the y-axis at 10. It's almost a similar case, but in this case, we're going to be doing plus 0, which means that we're not going to be starting either to the left or to the right of the vertical axis. When we're doing a horizontal position, we're going to be starting at 0, 0. This then results in, one, since our radius is 60 feet, we're going to have an amplitude of 60 feet, which means it's going to go either from negative 60 to positive 60 as your position on the Ferris wheel. And then our period is going to be 60 feet, our period is going to be 60, which is meant to actually be time, 60 seconds, because that's how long it takes a Ferris wheel to rotate. You might be wondering what it looks like to graph the horizontal position. And if you graph it, it almost looks exactly like graphing the height. But in this case, the midline is going to be 0 because there's no additional added feet, because horizontal position always will stay at a y of 0. Now, in this case, we can look at the period, the amplitude, and the midline. And we already know midline is going to be 0. The amplitude is still going to be the same as the height, and the period is also going to still be the same as the height. Both are going to be a positive of 60 feet or a negative 60 feet for the amplitude, or a period of 60 seconds across both. Now, if we go to actually, what happens when you actually start changing factors? Now, if you start changing factors, for example, if you change the radius of the circle, it will change the amplitude. Now, if you were to double the radius, that means that it would have to move, the degrees per second would start, the wheel would start to rotate faster. It would still be moving at 6 degrees per second, but 6 degrees on a wheel that's twice as big will mean twice as amount of feet per second, which means that the waves will get bigger, or, well, it'll appear more contracted. Now, if you change the midline, I don't really know what this would look like, and this would actually create an oval-like shape, actually, and that will put, for example, if we added 10 to we added 20 in this case to the midline, it'll just push the entire graph up. Now, if we change the period, which is rotation speed, the distance, the amount of time it takes for the person to go around the circle will either decrease or increase, which means the waves will get smaller or bigger.
Coterminal angles are angles that are in the same position and have the same terminal side. So to find the coterminal angle, you can either subtract 360 or you can add 360 from the angle. That's because there are like 360 degrees in an angle, in a circle, I'm sorry. So if you go around 360, you end up in the same spot, or if you subtract, it'll be, the same spot. So an example would be 20 degrees plus 360 degrees equals 380 degrees. So, 20 degrees and 380 degrees are coterminal angles, since they're the same. And another example would be 20 degrees minus 360 degrees equals negative 340 degrees. So negative 340 degrees is also a coterminal angle of 20 degrees. So reference angles. So reference angles are acute angles that are used to represent other angles, and they must be under 90 degrees. So how do we find the reference angle when the coterminal side is in the second quadrant? What we have to do is we have to do 180 degrees minus x degrees, so the amount of degrees that you want to use to find the reference angle. If it's in the quadrant 3, then you have to do the amount x degrees minus 180 degrees. And if you're in the fourth quadrant, you do 360 degrees minus the amount of degrees that you want. So the unit circle is used to find equivalent sines and cosines of different angles. So basically, the x-axis shows the cosine and the y-axis shows the sines. So basically, you just have to find which lines correlate with each other. And so some examples of this, when we can look at the graph, is cosine 60 equals negative cosine 120, which equals sine 210 and cosine 30. So, and another example is also cosine 325 equals negative cosine 225 equals sine 135, and that equals cosine 45.